I used an AI coding tool recently for what I thought was a tiny change. Just update one piece of logic and fix the test around it. But then I looked at the difference. It changed the file that I expected, which was great, but then it also touched the files I did not ask it to touch. Added helper that already existed, imported a library for something that the repo already had utility for. And I just thought, okay, technically this is correct, but does it belong here? That is the real problem with a lot of AI coding tools right now. They're getting very good at making changes fast. You ask for a function, they'll write one. You paste in an error, and seconds later, you have a patch that looks convincing. But speed is not the same thing as understanding. If you have worked in a production repo, you know this immediately. A codebase is not just a folder full of files. It has history, patterns, shared utilities, tests, and all the weird decisions that usually exist for a reason. So when an AI tool starts editing before it understands the systems, it can create very fast chaos. Let me give you an example. Imagine your app has a service layer. Every database call is supposed to go through that layer because that is where permissions, logging, retries, and error handling happens. Now you ask your AI tool to add a new endpoint. If it only looks at the files that you're editing, it might just write a direct database query inside the endpoint. At first, that sounds fine. It returns the right data, maybe even the test passes. But architecturally, it is wrong. It is bypassing the service layer. It skips the place where permissions are enforced. It creates a pattern someone else might try to copy later. So the code works, but the system got worse. That is why the question cannot just be, can AI write code? Clearly, yes. But the better question is, can it write the code that respects the code base? Because in production, a good code is not just code that runs. Good code fits. First, we have repo awareness. The AI needs to understand more than the file in front of it. A real coding task are rarely contained in one file. A small change might affect type definition, an API contract, a test, or documentation. No one remembers that even exists. So before the AI asks, what code should I write? It should ask, what do I need to understand? And note, that does not mean dumping the entire repo into the prompt. More context is not always better context. If you give model thousands of irrelevant files, you're just hiding the useful signal inside more noise. Good repo awareness means finding the right context at the right time. Relevant files, existing examples, tests that matter, and code that already solves a similar problem. Second, architectural context. Architecture is not just where the file lives. It is the set of rules that keeps the system maintainable. Where should the business logic go? Where does validation happen? Which service owns this data? Or are we even allowed to add dependency here? When an AI tool ignores those rules, you get the code that works but feels foreign to the repo. Maybe it imports a new library when the project already has standard utility. Maybe it writes a helper that duplicates something that already exists. None of that feels catastrophic in the moment, but over the time, this is how code bases get messy. Third, we have planning before patching. The first output from AI coding tool should not always be code. Sometimes the first output should be understanding. Before it changes anything, it should make its reasoning visible. It should say, here are the files I checked. Here's the pattern that I found. Here's where I think the changes should go. And here is what I recommend doing next. And then it can write the code. That pause lets developer catch mistakes early. You can say, no, do not touch that package. Use this existing service instead. This is how real collaboration works. Good engineers align first. AI tools should do that too. AI-generated code is very good at looking right. The names are clean, the structure looks familiar, the comments sound confident. But confidence is not a test result. A code-respecting AI tool should run the same checks a developer would run. Unit tests, type checks, linting, build commands. But verification should go beyond did the test pass? It should also ask, does this change still fit the system? Does it follow the existing pattern? Did it respect the architectural standards of the repo? Or did it introduce a shortcut that might cause problems later? Because in production, a change can work and still be wrong for the system. And if something fails, a tool should understand the failure and not just randomly edit until error disappears. That is the difference between debugging and guessing. And finally, boundaries. A good coding agent needs to know what it can touch, what it should not touch, and when to ask for approval. Should it edit deployment files or change authentication logic, install dependencies? For most teams, probably not without reviews. It should work on a branch, run tests safely, avoid secrets, and ask before doing anything risky. Basically, it should have manners. It should knock first. So the workflow should be simple. Read first, plan second, patch third, verify fourth, and review last. Not patch first and apologize later. And as developers, we should be just as intentional. Point the tool to the right files, show the existing pattern, tell it the constraints, ask for plan before code. Because if the instruction is vague, the model fills in the gap. And in software, filled-in gaps becomes bug. The future of AI-assisted development is not just faster code. It is more context-aware code. Tools that read before they write. Tools that understand before they modify. Tools that preserve architecture instead of just casually reinventing it.